think we're set to record. I had to move a few things. This is just the first video in terms of, well, the other day I did a live stream, and here are the analytics. It was only a few days ago, but we've already gotten almost 300 views. It's rather impressive for me. I'm not really big time yet, but I do want to show people what I'm capable of doing and perhaps grow from there, right? So getting this kind of feedback is really encouraging. And unfortunately, I'm not really in a good position to live stream. So I'm going to try and take advantage of my setup here. I'm able to record snap after snap of video and it stitched them together into a longer video. So I want to attempt to make a long form video of my programming efforts. I'm a bit late getting started, and I'm going to have to take a break here in a second just to take care of a few things like feeding my grandma's dog and making sure she's gone out to potty. But once I get back, we're going to be diving into where I left off last time, which is actually taking a look at the performance of how many entities I'm able to comfortably render on screen. I did some measurements earlier, and around 5,000 to 6,000, we're still getting like a full 59 FPS, which is pretty good. But around 7,000, we get a little bit of a drop off in performance, which may not matter right away. And I'm already seeing opportunities for me to recode things, which is really annoying because, for instance, to access any texture information, the way I have done it is the sprite is a pointer and the texture is also a pointer on the sprite. So there's two memory accesses that have to occur before you can actually render any texture information. So it's definitely possible that this can all be optimized. For instance, creating a level 1 object, and by that I mean an object that doesn't require a second reference to access the texture. So we can have the texture information so what I'm talking about here, so the way that I've implemented textures is that the texture class is a wrapper around an SDL texture. So already there's 3 levels of indirection that have to occur in order to actually access the texture. So drawing is kind of expensive in this regard. And if there's a way that I can flatten out that process, I'd like to. And maybe I can actually do that since I'm not doing it on stream. And I can actually kind of try to work through this step by step. The problem is loading the texture actually ends up being this class actually takes care of a lot for us. And I initially pulled it from this dude, LazyFoo. He's got this big list of tutorials, and I kind of went through and followed a good chunk of it, kind of to get my initial understanding of SDL. But then I've been looking at entity component systems, and I found this really good blog post with a very simple implementation. And I thought, wow, this is so simple that it wouldn't be too far of a stretch to try and implement sprites and animation in something this simple. But it's going to require re-engineering how I do a lot in my current engine, which is very frustrating. And if we can avoid doing that, that'd be nice. But at the same time, I am a perfectionist. I'm obsessed with optimization. And so if I can optimize, I'd like to. Um, Taking a look at how the sprites are implemented. Sprite has a shared pointer to one or more sprite sheets. And you have to pass in a texture. So the implication is that in order to implement animation, you have to have the width and the height representing the rectangle for like one individual sprite. And then you have to have a number of clips in the texture so that we know how many frames that we have to iterate through. This way, because every frame, the next rectangle that renders is a multiple of that first rectangle. It's just basic geometry. So if there's a way that we can reduce the number of memory accesses required to implement this, then we should be able to get even more objects on screen without losing any sort of performance. Taking a look real fast. So I'm recording right now, and we got 6,101 eyeballs. Well, 6,000 eyeballs plus the skull. All on screen, rendered and then stretched at 4x. And on my end, it looks pretty smooth. And I'm recording this video at 30 FPS. So keep that in mind whenever it looks a little bit choppy. But this looks pretty good so far. And it feels good. And it's all smooth, but I fundamentally know it's not optimal. Just based off of how I've written things so far. We're kind of doing a hybrid entity component system and object-oriented system at the moment. And I'm probably going to continue, but I want to consider how we can actually smooth out the number of memory accesses required to actually do textures and sprites in animation. So the way that they do it in this blog post, I actually don't even have animation in the blog post, but the sprite is a component consisting of a rectangle source, a rectangle destination, and a texture. So the rectangle destination is the interesting part. Because the source is actually the part of the texture that you want to actually grab and render, which will change if you're doing animation. But the destination gets pulled from the transform. So any position changes in the transform get copied over into the sprite. So you don't actually have to pull from the transform in order to get that because they already copy it over during the update. So implementing a sprite would probably be a matter of adding an additional integer to this whole system. The question is, do we want to do this from scratch? How quickly could we do it from scratch? Do I even need a surface? I don't even know that I need a surface. Oh, this actually rips it out. Oh wait, I've got a thing I have to add to my NVim. So I want to do like double right arrow or double left arrow. Normally we'll shift over by one, but you can also do like normally hit V down in visual mode and then also greater than symbol and it shifts over. But I want to be able to do greater than F in order to shift down the current line as well as, or to shift over the current line and the next line. So I don't know that that's a good one. Shift K. Yeah, that does not work. Oh no. In normal mode, if we do that, then that should be equivalent to that down and then shift again. So let's try it. Okay, that did not work. Oh, no. Okay, got it. There we are. That's pretty good. So the opposite motion would be less than F, which would be shift left, shift left. Oops. Yeah. Shift left, shift left, shift left, shift left, but not J. But uh so oh not that needs to be D. All right. There you go. Okay. All right. So back over here. Image init. Let's do an initial compile. Whoops. Oh. Uh. There we go. Okay. So there's our window. we're doing this shit from scratch, and we're going to be re-implementing a lot of what we already have. But the whole idea here is that we want everything to be super fast, and we want to be able to render far more on the screen than we're currently rendering. So by trying to eliminate bottlenecks and streamline the program, we're going to attempt to achieve this. This is a start, and with Copilot's help, we're going to make some significant strides. And we do not have a make file yet. But the idea here is that we're going to get into a feedback loop. Go ahead and copy over some image stuff. Y'all's job now is to guess what song or music, band, genre. You have to guess what I'm listening to. Ooh, this is a good track. All right. Pause the video and try to take a guess. And if you have already guessed, it is Beauty Coliseum by Maximum the Hormone. Is load texture a thing we can use? Yeah, see, that doesn't even exist. So this has to be nice. Good start. Now it actually renders like the whole screen, but it's a good step. Leave off. Hmm. Right, right, right. Okay, so we've got a new repo now. I don't really ever make a commit message with actual information for the first commit, just the fact that it's the first commit. So we're rendering, but it's too big. It's like stretching the texture though. This isn't quite right. I think this is still going to stretch it, right? because we're not defining an endpoint for render copy. Like render copy, yeah, see, we're supposed to have a destination rectangle. So there we go. That's the correct size of the skull. So everything is working as intended at the moment. But else if e.type equals SDL key down. We're getting to the point where we're going to need to refactor a bit. But not the clip, but dest. But that's not actually what I wanted to implement. I wanted to do case. Looks good. Oh, that's terrible. It only moves in two directions. It's also trying to do by clips. There we go. But naturally, I'm encountering the same kind of lack of smooth movement that I was experiencing the first time I've redeveloped this engine so many times at this point. So the lessons I learn every time I do this stay with me. So in order to get smooth movement, what we're really going to have to do here is, instead of incrementing whenever we get the key event, we need to trigger when a key press is on or off. So as an example of this, left is pressed equals true, right is pressed is false. Actually, we'll start with false too. Now, as an example, we'd actually be able to make the destination larger and scale up the size. But instead of incrementing here, what we're going to do is do left is pressed, and then right is pressed, and then else if key presses key up, then it's going to unpress those. Now, so this is effectively the input loop, right? Down here, we need update game state, and then render frame. So why does it keep doing skull clip? That's stupid. Oh, that's like really fast. I guess it appears that fast because of the resize. Whoa, why is it so fast? Jesus. God damn, that's fast. Well, I guess the effect that I ended up discovering was that if everything starts off at the smallest, then you can render to a to another texture, and then render that texture, and then you effectively have your game rendered onto like a sheet of paper, and you could stretch it to whatever size that you want. So if you want to design a game in 800 by 600 and then scale it up to what is it, 1600 by 1200, or stretch it to whatever size that you want, while still designing the game in 800 by 600 or whatever your base target size is, you can do that. So that still feels really fast. So here we're rendering a single texture to one location and moving it around on the screen. The next step is we're going to render that texture to a target texture that we're going to stretch to fill the whole screen. Okay, where did I leave off again? Oh, right, we're doing the texture, target texture. So the idea here is that you have a screen that you're rendering to, or rather your window, and this window has a surface, and we can render to that surface a big texture that is the same size as that window. Or rather, we can take that texture, render it, and then scale it or stretch it if we need to. That way, if we need to do any sort of stretching operations, there's only one stretch that we have to do. So target texture is going to be our object. So I declare the integers as target texture width and height because what we'll be able to do by the end of this is multiply the window size and have the texture scale with it. Okay. So far, so good. So that clears the screen, but we also have to clear the target texture. So to prove that we're actually rendering the target texture, we first clear the screen with red to represent like the base screen background, cosmic background radiation. And then we set the render target to the target texture, set the render draw color to blue, and then we clear again. So at first it goes red, then blue. You might say this is an unnecessary step, but I'm doing this to like show that one context is rendering over another. So when you reset the render target, you are now rendering to the screen and no longer the texture. Because at this point, we've drawn everything we want to the texture and can then just render it directly to the screen. So over and enter, everything compiles fine. So it's showing red at the moment because something is wrong. We're missing something here. See, it's messing up now because I'm not doing it properly. See, Oh, we're never actually rendering the target texture. That would make sense. There we go. Now it's rendering properly. Now to show what I'm talking about here, when we go to actually create the window, we're going to double the size of the window. So that actually scales the whole thing. Now, when we copy the target texture, it's automatically scaling everything up for us. But see, now you can see it's only rendering in the top left corner. So that's the target texture, and I'm only rendering part of it. Like, I'm rendering it, the whole thing, but I'm not like taking up the whole screen in order to do it. Now, watch this. We take that and multiply it by 2, or in other words, set it to the window width and height. Now it feels more appropriate. One thing we can do, make this 320 by 240. I'm calling this zoom. It's just like a throwback to the variable name that I used to use a long time ago. So in other words, this would actually be window width, window height. That's more appropriate. Now we would actually prefer this to be like, oops. So 800 by 480 would be 240. That feels good. Gonna need some more coffee here soon. Now, let's go and do up is pressed and down is pressed. Now, it's not else if. Actually, it is. Because you can't have both left and right pressed. It's still a little fast, though, it feels. Hmm. Leave off. Um, let's see, we did the up, down, left, right thing. Still feels like kind of fast, though. Oh, wait, don't we need to like set the frame rate somehow? Isn't there a way to do that? It's a good track. Called Oh Shit by KMFDM. So, this will actually create a target texture, which I believe is an actual texture, like objects. So the way I do it over here, gotta be a place where I swear I was locking the FPS somehow. Guess not. Maybe the lag in the rendering operations is so bad that it caused it to appear to be slower than it actually is. We're not doing the VSync, um, which might explain for it actually. Where we actually create the renderer. Here we are. There we go. Okay, that makes sense. I was like, why is it so fast? This makes way more sense. So code is starting to get a little bit unwieldy. We will require some refactoring soon. So let's go through and do a little cleanup. Classic style cleanup, right? Which means moving variables towards the top of the program. Historically, in old school C and C++ programs, and it's just good practice in general to like kind of organize all of the different buckets and containers that your program might be using into one central location. Now, naturally, this is not a complicated program yet. So everything's shoved inside the main, which is really not a good practice. Everything still compiles and runs, I think. Yeah, it's like compiles really fast. Oh, wait, what? Okay, there it is. So naturally, this is super basic, but it has a lot of the same moving parts that the much larger mini lined version that I have in the other repo actually doing. So one of our goals is to turn this into an entity component system. We also want to make use of shared pointers where possible. Do we need to use them for SDL window, render, and texture? As far as I can tell, they're the only pointers that we're actually using. I'm not sure that you can pass a shared pointer renderer to SDL methods. I'm not sure that you can pass a shared pointer to a render target function. We can try. So we're going to try an experiment. We're going to see if we can, after I make this commit, we're going to do a little experiment. Sorry to stop the recording process and do this, but fuck. Um, all right. So, sorry, back to it. Doing a little experiment here. We're going to use make shared pointer. Those start off that way, but to declare it as a shared pointer, so where will this break? Will this work? I was never bought it. That's not the lyrics, is it, though? I was up above it. Huh? Wait, can I not do that with make shared? Oh, I guess yeah, because of the what we're actually passing. Does this actually get the mm, yeah, I don't think this is gonna work. Damn it. Oh well. Well, guess we're not at the point where we need that yet. Okay, we're back. That was a fun little diversion. We'll move on to getting the debug panel up as well as rendering the eyeballs and doing animation and collision and components and all that good stuff. So in the old system, this is our load from rendered text, which very much runs every frame. So every frame we're having to generate a brand new texture. It's not the most efficient way to do things. I've read blog posts on essentially using your own textures or sprites with each like character kind of sliced out into its own font like texture and then like constructing text that way. That's a lot of work. That's more work than I'm willing to do. So something like this should be fine, but we're going to need to essentially finagle this into a simpler format. What we do here is we create a surface that we load from a rendered text. So we have to have a font loaded. Might as well link it ahead of time. So we're going to need to declare a SDL texture debug texture. Now, texture, we have to first do this. We didn't include imprint. Oh shit. Imprint is my magic debugging code. Define imprint to be the following, and then you can pass in this big long thing and your message right here. So it gives you back date, time, file, and line number, which is very useful for debugging. Way beyond printf debugging. This is printf debugging on steroids. So let's see it in action. This is going to be a debug texture. Oops. Remember, this is good. Text color. Yeah. Let's do white. Let's do that. Okay, that looks good. Okay. So this will load it once, right? I think in the other one, I was actually rendering a kind of a transparent black block behind the text when I render it. But for right now, let's just render the text. This renders the text. No. So this copy's there, but then we want to render the debug text. Is there anything to see? Let's go. Nope, nothing yet. Debug texture. Wait, did we get any errors? It's running. Unable to render text surface. Oh, whoops. First, yeah, no, we're missing a couple things. We have to see. Oh, we never initted TTF. Okay. Yeah, we don't actually need a whole lot there, but we need to copy over. There we go. Do 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 la 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 la. Do 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 do. Hmm. Wait, did I not do the left motion as well? Mm. Oh, sick. That's pretty fucking awesome, actually. Um, totally unexpected for it to stretch like that. I guess we didn't specify a target destination for the. I guess the debug texture does have technically information on it that we can use. So we get a text surface. Actually, we can use that information before we free it in order to specify like how big the text should actually render as. So back over here, we're gonna specify another. This is gonna be debug texture source and then destination. So back when we load the text surface before we free it, um, too big. Too big. Way too big. I guess it is being stretched to along with. Yeah, that's true. Okay, wait. Now I know what the problem is now. It's we're we're actually rendering this to the target texture and then stretching it. What we want to do is actually render it after we render the target texture. That's much better. See? So this actually makes sense now. Now just for funsies, this is a good track too. This is materialism as a means to an end. Let's see. Okay. Now, to fuck around a little bit, texture. Texture text. Let's just do 1028. But we want to have the last now this will be the first real good opportunity to have a function. Now it's not, oh, there it is. It's only updating every so often though. And it's not doing um That's interesting. Now, if we didn't free the surface all the time, we could actually optimize this a little bit. Text surface. There we are. So we actually don't need to get rid of the surface. Um, this could be not good though. Um, sprintf. Oh wait, no, that's correct. Mm, um, okay, destination, texture, text. Nice. Looks good, but the it's still stretched, and it's the size is based off of the initial text. So I think, yeah, Oh, let's do there we go. That's pretty good so far. We're making real good progress. Not to mention everything is contained in one file, which is rather impressive. These two will go up here with the rest of the integers. And these three will go we can put these down here. Oops. Hmm. Like, can Copilot write me anything? Whoa. But there's so many pointers, though. There's so many memory references. How many of these can be actually how many of these can actually be pulled into the global context? Because then we can just call a function to load it. Okay, everything still works. That's a commit. Oops. I gotta fucking piss though. Oh, pee time. I think the code base is starting to get a bit unwieldy. So if we wanted to do something a little bit crazy just for funsies, the traditional refactoring function declarations go at the top, and method implement or function implementation goes at the bottom. So if we wanted to generate some random text and render it using sprintf, at the beginning of main, we're going to srand, and down in our text generation, for instance, let's say we wanted to generate a random character. Nice. That looks fucking awesome. So this isn't the cleanest way to do it. And if we wanted to make it a range, like from A to Z, we have to subtract something, I believe. Do a little basic math here. So ASCII table, right? So this would give us 0 through 26, right? Or 0 through 25, rather. Um, and then we add lowercase a. So lowercase a ends up being our offset. So that way, if we get 0, it comes back as capital A. And if we get 25, it comes back as capital Z. So to take advantage of that, we would generate random char. It's pretty sick. Now, for every occurrence, it's pretty sick. Four, five, six, seven, eight. 16. Oh man, that's looking fucking awesome. So when we let's do something a little bit fun, a little bit more fun, even more fun than what we're doing already. Check this out. So instead of rendering to the debug panel, hold on. This track is too sick. I gotta like this shit. This is a good track. Winning by Flappy Bird. It's not SB, but it's got that vibe though. So this is going to be null pointer 2. Too short though. Um, so debug textures destination. Window width, window height. Something ain't working right there. Um, 400 by 240. Hmm. Um, uh, the source. Hmm. That kind of looks sick though, honestly. We could do like a little demo where we like render the text Evil Dojo. Huh. Wait. Ain't working. Why ain't that? Oh, wait. The frame count's never increasing. Ah. Hmm. That's starting to look pretty good, actually. How does that look on video? Oh, wow, yeah, you can't even see it on video. Um, how is it looking on? Let's see. Yeah, so you can see it here, but we want it to like every so often stop. So essentially every so often, if this is kind of for like for demo purposes only. All right, not bad. We could even turn this into a Quine by rendering the source code for the game in the background. That would be kind of a good project. I realize this video is getting pretty long too, so let's get back to some sanity here. Uh, all right. So essentially, to turn this into a component system, we're gonna have to create a little struct to contain the texture as well as its source and destination rectangles. So we can do something like type def struct um, transform would be double X, double Y. Time to bust out the vectors. So debug texture, source and destination. So when we go to actually create a component, So here's our sprites, here's our transforms, right? So adding a component is this easy. Um, then pushing back a transform's that easy. Now, we need to have some sort of association between each. And actually, vector's not the right thing for us to use here. Actually, unordered map is pretty great for this. Actually, this is going to be an unordered map of int to that. Actually, it's not going to be int. It's just a placeholder. Um, all right, so now we have two unordered maps, and instead of pushing back to them, so if we wanted to generate a new entity ID, it would be like that. But we want this to be a bit more dynamic. So instead of skull idea, so here we can make the next entity ID like that. So naturally we would have to increment it, but we want to kind of handle that for us. So we're going to create a little method that's the next entity ID. Very straightforward, super easy. That's a lot better. So now anytime we want to get a new entity, we just get the next entity ID, and then we add the items to the map. So we're gonna temporarily disable updating the game state. Now, so this will actually go through every item in sprites and grab things off of the key value pairs. Actually, we could add this to a vector of IDs. So adding the vector in. So the entities vector just contains the IDs. And now for auto ID in entities, now we can access the sprites. Very straightforward. It'll be interesting thinking about how to get the debug texture into the component system. Everything looks good. Okay. Renders. That's good. So what's the next step here? For the moment, I think let's just temporarily disable the rendering of the debug texture. So adding the input component. That's a good track too. It had me looking up a few times. So inputs. The only thing that should be in the inputs array or the inputs map is the player. So here we update the transforms. Um, we actually don't need sprite yet. Now we've updated the transform. This isn't error safe. But if there is a transform, let's see. Hmm. Oh, wait. Hmm. Oh. Oh, yeah, this won't work. Hold on a second. So I realized what I was doing wrong here. So we have to, just like in the loop below, reassign the transform back to its location in the map. Now we can move around again. Excellent. Sweet. I think that's going to do it for tonight. This video is starting to get pretty long, and this represents a good checkpoint. In the next session, I'm going to get the eyeballs back on the screen. We're also going to consider how to get the debug texture as a entity in the system. And we'll also get collision detection going again. And we will also take a look at implementing some of that functional stuff that I did in the previous video. There's a lot of material here, and I'm having a lot of fun making shorts. We've got a lot of new viewers out of the shorts that I've been making. A lot of the dog content in particular, but the fun has just begun. Until next time, everyone. Evil Dojo signing off. Check out the socials right here. Same on all 3 platforms: Twitter, YouTube, Twitch, at Evil Dojo 666. Happy Easter.